And really the key to this is looking for the alternative rational power or the alternative exponential forms. And so if I gave you something that looked like this, okay, rather than thinking of this as 36 to the 1/2, what do you recognize about the number 36? Is it a perfect power? Yeah. So if you can find perfect powers, almost every problem that you're going to be dealing with in this section or this portion of this section, you're going to be looking at perfect power. So if you look at 36, 36 can be expressed in what alternate exponential form? 6 squared. And if you took 6 squared to the 1/2, what's going to happen with your powers? They cancel. 2 times 1/2, those cancel, leaving just your answer 6. And now, it doesn't mean that's the only way to apply it. You can think in terms of radicals. Okay, so you could have thought of this in its radical form. Index of 2, base of 36, power of 1. What is the square root of 36? 6. So you could think of it in those terms as well, but it's probably the most useful to find those perfect powers. Use the alternate forms. Okay, so I want you to try these two examples here really quickly. Okay, when you're evaluating these, you can apply either the index first, which is also an nth root, or you can apply the power first. Okay, or you can rewrite the form. Okay, so in each of these cases, I'll go through kind of the two different ways you can approach it. So let's say you rewrite the form of this. Well, what do you notice about 125 and 27? They're both perfect what? Cubes. 125 is 5 cubed, 27 is 3 cubed. So if you think of it in terms of that alternate exponential form, what you can do here now is you can apply this negative power. The negative is going to flip our base, so it becomes a 3 cubed over 5 cubed to the positive 2/3. Again, that's just the property of a negative power. And now when you apply this power to a power, you're going to get 3 to the 3rd times 2/3, multiply. The 3 and the 3 cancel, leaving just 3 squared. And then you apply that power to the denominator, 5 to the 3rd times 2/3. Again, the 3's cancel, leaving just the 2, 5 squared, which is going to give you your answer of 9 over 25. Okay, now, the other way that you can think of these is you can simply apply the denominator, which is your root, first. So again, what I would probably do is apply the negative power first. So the negative power is going to flip my fraction. And now if you apply this cube root, what is the cube root of 27? 3. The cube root of 125? 5. So that whole thing is taken to the power of 2. And so you get 3 squared over 5 squared, which again will lead you right to your solution, 9 over 25. Okay, so you can either apply, treat it like a radical, or you can treat it like the exponents written with the smallest possible base. Okay, so this second example is another case. 81 and 16. In both of those cases, you might recognize that those are perfect squares, but they're perfect squares of a perfect square. So they're also powers of 4. Often the index, or the denominator of your rational power, will kind of give you a clue as to what perfect powers you're looking to rewrite them as. Well, here, since this is a 4, it's possible that these will both be perfect powers of 4, and in fact they are. This is 3 to the 4th over 2 to the 4th to the power of 3/4. And now you can apply your power to a power. You get your base of 3 to the 4th times 3/4. Well, the 4's cancel, leaving just the 3. Your base of 2 to the 4th times 3/4. Again, the 4's cancel, leaving just your 3. And you get 3 cubed, which is 27, over 2 cubed, which is 8, for your answer. Okay, you could also, like I said, apply the 4th root first. Well, the 4th root of 81 is 3. The 4th root of 16 is 2. That whole thing cubed, which is then going to lead you directly to 27 over 8.